So 3.5 is all about using corresponding parts of congruent triangles. Back in the beginning of the chapter, I think it was in section 1 or section 2, we talked about corresponding parts of congruent triangles already. We're going to use that inside of proofs now. Okay, so what's going to happen here is if triangle ABC is congruent to triangle DEF, then all of the corresponding sides and all of the corresponding angles are going to be congruent. So this is called CPCTC. Corresponding parts of congruent triangles are congruent. So we're going to start using this inside of proofs now. So really all it's going to do is add one more step onto the proofs that we've been already doing. And again, from the picture, you can see this side corresponds to this side. 2 hash marks corresponds to 2 hash marks. 3 hash marks corresponds to 3 hash marks. And the same thing with the angles. Okay, so here's what we're going to do again. We're going to prove first the 2 triangles congruent by one of our 5 methods. Then we're going to use this CPCTC to prove whatever it is that we're looking for, whether it's a pair of line segments or a pair of angles. So given that D is the midpoint of BC and AB is congruent to AC, we want to prove that angle BAD is congruent to angle CAD. So the first thing I'm going to do is I'm going to highlight these 2 angles in purple, and then I'm going to change my pen. Okay, I want to prove that BAD, that's this angle here, is congruent to CAD, which is that angle there. They're not congruent already, so I'm going to change my pen color again. The purple, we do not know yet. That's what we're trying to prove. So in order to do that, if I can somehow prove that this left-hand triangle is congruent to this right-hand triangle, then those 2 angles are going to be corresponding parts of congruent triangles. So anytime that you have an angle as your prove statement, I don't know where prove went. Okay, and that should be that. Something happened with this converting to a midpoint there. That should be D is the midpoint of BC, and we want to prove there. My proof is down here. I don't know what happened when I converted this to a PDF. I didn't like it. Okay, so if I could prove those 2 triangles congruent, again, I'll be able to say that the 2 angles are congruent by CPCTC. Okay, so our first step is D is the midpoint of BC. And again, the reason we know that's true is it's given, and let's stick our other given in there. And AB is congruent to AC. Okay, so AB is congruent to AC. I have that marked off. And now let's talk about the fact that D is the midpoint of BC. I want to use all my givens first. So if I have a midpoint, that means it's going to cut that line segment into 2 congruent segments. So that means that BD is going to be congruent to DC. And that is because of definition of a midpoint. Okay, I only have one other option here. Please do not assume that something forms perpendicular lines if you were not told that they were perpendicular lines. Okay, so do not assume that this angle down here and this angle down here are right angles. You were not told that you have perpendicular lines. You were not told that you had right angles. Do not assume it. Okay, the only other thing that you can get from this picture is that AD is congruent to AD. And again, anytime that you have something equal to itself, that's the reflexive property. And now I have enough information to say that the 2 triangles are congruent because of side, side, side. So triangle ABD is congruent to triangle ADC. And that's because of side, side, side. But again, that's not what we wanted to prove. We wanted to prove the 2 angles are congruent. Well, now that I know that the 2 triangles are congruent, now I can go ahead and say that those 2 angles are congruent. So angle BAD is congruent to angle CAD. And that's because of corresponding parts of congruent triangles are congruent. Okay. Instead of proving 2 angles are congruent, we're going to prove 2 line segments are congruent. Again, literally all we're doing is adding one step to our proofs here. So again, I'm given that BD bisects angle ABC, and that BD is perpendicular to AC, and I want to prove that AD is congruent to CD. So again, I'm going to highlight this in red, but then I'm going to change my pen. I want to prove that AD is congruent to DC. I don't know that. That's what I want to prove. Okay, so AD is part of this left-hand triangle here, and then DC is part of that right triangle there. So if I can prove those two triangles congruent, then I'll be able to say that AD is congruent to DC by CPCTC. So again, let's get rid of our givens. BD bisects angle ABC, and BD is perpendicular to AC. And again, the reason that we know that's true is because it was given. So let's use the two givens and figure out what our next steps are going to be here. So let's get rid of the BD bisects angle ABC. Okay, well, if BD bisects angle ABC, again, bisects means cuts into two congruent angles. So angle ABC is this entire top angle, which means that this little angle is going to be congruent to that little angle then. So angle ABD is going to be congruent to triangle DBC. Oh, over to 3 again. I have a habit of doing that. Okay, and that is because of the definition of an angle bisector. Let's use our other piece of given. BD is perpendicular to AC. If BD is perpendicular to AC, that means I'm going to have two right angles there. Okay, so the next thing I'm going to say is that I have my right angles because of perpendicular lines. So I'm going to say that angle BDA and angle BDC are right angles. And that's because of definition of perpendicular lines. Okay, and now the next thing I'm going to do is I'm going to say they're congruent. Hypotenuse leg isn't going to help you here because hypotenuse, the side across from the right angle, there's nothing from this problem right now that I can tell you about AB or BC. So hypotenuse leg is not going to come into play. So I am going to have to use the right angle as a congruent angle with something not as part of hypotenuse leg. So now I'm going to state that those right angles are congruent. So I'm just going to state that angle BDA is congruent to angle BDC. And again, that's because right angles are congruent. Okay, and now I need one more piece of information. Again, I have this angle up here now, and I have this pair of angles down here. So I need one more piece of information to prove the triangle's congruent, and that's going to be that BD is congruent to BD. And the reason that that is because of the reflexive property. Okay, and now finally, again, I have enough information to say that the two triangles are congruent. So the triangle on the left is triangle ABD, and the triangle on the right is triangle BDC. And again, the reason that is because you have an angle, a side, and an angle. So that's going to be angle, side, angle. And again, that's not what I wanted to prove. I wanted to prove that AD is congruent to CD. Again, the two pieces that are marked off in red. And now the reason that those two things are congruent is because now they're corresponding parts of congruent triangles. So those two things are going to be congruent by CPCTC. And you are done. Literally all we're doing is adding a step. Okay, so the last step is always going to be the two things are congruent by CPCTC. You just need to figure out the triangles that are congruent first.